Okay, this is a video on intersections of lines. Okay, I made up this question and it is a terrible one, but anyways, it'll still make my point. Okay, so you have a TV streaming service and it has two different monthly plans that you can choose from. Now, plan A just charges you a flat rate of $30 per month, no matter how many shows you watch. So who wouldn't choose that one? But anyways, plan B charges you $9 per month and you have to pay an additional $3 for every show you watch. Not a great plan, but anyways, let's compare them. So these types of questions, they're not opinion questions. So you wouldn't answer this with like, oh, I would always choose plan A. Because why wouldn't you? You can watch as many shows as you want. True. But since this is a math class, we're trying to figure out the math involved here. So we want to compare them and we want to figure out exactly when each one is cheaper. When are they the same price? That's our goal. All right, so this guy's going to be easy to graph. It's just charging you $30 a month. Okay, so I already made a graph. I put cost on my y-axis and number of shows on my x-axis. And then I just made a scale. And now, okay, I'm going to graph plan A in black. And it's charging us a flat rate of $30 per month. So if I wanted to make an equation for that info, the equation for plan A that I would say like C equals 30 because the cost always equals 30. Or if you prefer Y's and X's, you could say Y equals 30. And it's just 30 all the time. So when's the cost going to be 30? Forever. So the cost is always 30 for this plan. So that's plan A. Okay, I'm gonna put plan B in red. So plan B charges us $9. So that's kind of like our constant fee, or it's gonna be our y-intercept. And then $3 per show is gonna be our slope. So for plan B, if I wanted to write an equation, I could say cost is equal to $3 per show. Let's say show was like N, plus $9. Or if you love X and Y's, Y equals 3X plus 9. So that'd be how I write the equation. And now I'm gonna graph it. So I know it's gonna start at $9. That's the flat fee. So even if I watch 0 shows, it's gonna cost me $9. Now if I watch 1 show, it's gonna cost me $3 for that 1 show plus my $9 initial fee. So that's gonna cost me $12. Put a dot at 12. So it's gonna go up by $3 every single time I watch a show. So, sorry, I'm gonna do that real quick. Going up by $3 every time, which is why I chose to go up by 3s on my scale. Clever. Okay, there we go. Now I'll just try to make a straight line here. Okay, there we go. That is plan B. It's always good to label your lines too. Plan A, plan B. It's very clear. Okay, so we can see that they intersect right here. That is, in grade 10, you do a lot of intersecting line stuff. We call them linear systems. And the solution to them is always the point of intersection. So where do these guys intersect? They intersect at 7 shows and $30. So 730 would be the coordinate that they intersect at, I think. Yeah, that's right. Okay, so it looks like, looking at my graph, that plan B, I would say plan B is the cheaper plan when you watch less than 7 shows. But if you're gonna watch more than 7 shows in a month, then plan A would be your better bet. So plan A is the better deal if you watch more than 7 shows. if you watch exactly 7 shows, you could go with either plan A or plan B. But why wouldn't you go with plan A if you watch 7 shows? But mathematically speaking, they're the same price at 7 shows. So you could pick either plan at 7 shows. Okay, so that's in grade 9. I think you're just required to show this solution graphically. Like you can graph both lines and you can easily see where they intersect based on the graph. That's not super helpful when, you have an equation that maybe represents at not really nice, maybe intersects at not really nice numbers. So in the example on this page, I did show how to do it algebraically, but that's kind of a grade 10 skill. But I'm just going to show you anyways. So for anybody that does want to know, if I have an equation like y equals 30, and I want to know where is it going to intersect with this relation, 3x plus 9, that's the one we just did. I know that when they intersect, they're going to have the same y values. So what I can do is I can make these equations equal to each other. So I can like sub this y value in to that one, making it 3x plus 9 equals 30. So I've set the equations equal to each other because I know that they will have the same y value at their point of intersection. And then I just solved it like a regular equation. So I'm going to subtract 9 from both sides, giving me 3x equals 30 minus 9, so 21. And then I'm going to divide both sides by 3, giving me x equals 7. So now I know these two lines are going to intersect when x equals 7 and when y equals 30. And I can even check that over here. Y equals 3 times 7 plus 9. Y equals 21 plus 9. Y equals 30. Yeah, so these guys are going to intersect at 7:30. So this would be like an algebraic solution, which you never have to do if you don't want to. Graphical solutions are good. And you can find the intersection point of any two lines. And sometimes lines don't intersect, right? So let's say I have an equation like y equals 2x plus 1 and y equals 2x minus 5. Let's just say we wanted to graph those two lines. Okay, so y equals 2x plus 1. So I got a y-intercept of 1 and a slope of 2. So I'm just going to draw a rough sketch of this graph. And I'm going to attempt to draw a straight line. Pretty good. Okay, so that's y equals 2x plus 1. And then I'm going to draw my 2x minus 5. So 1, 2, 3, 4, 5 is my y-intercept. And I've got the same slope. Okay, and I'll draw a straight line. Hopefully, work out. Okay, check that out. That's the line y equals 2x minus 5. So this one seems like it might be hard to find out where these two lines intersect. What do you notice though? Look at their slopes. They have the exact same slopes, but they have different y-intercepts. Those guys are never going to intersect each other. So sometimes you can graph two lines and they might never cross. And the only time that would happen though is if they had the same slopes. Because do you guys remember what you call that? If two lines have the same slopes, they're actually called parallel lines. And they won't intersect each other ever. Okay, but maybe you have another set of lines like y equals negative 3x plus 4 and y equals sorry, 2x minus 1. And we want to know where they're going to intersect. So we'll graph them. Just going to make a grid. Okay, so then y equals negative 3x plus 4. So I got a y-intercept of 4. Got it. And then I got a slope of -3. So I'm going to go 1, 2, 3. Go like up 3 to the left 1. Or I can also go down 3, right 1. As long as my line's sloping down to the right, it'll give me a negative slope. So there we go. Take a little bit off. Okay. Man, it's hard to graph lines on this. Okay, there we go. Kind of. Okay, so that is the line y equals -3x plus 4. And then let's graph 2x minus 1. So I get a -1. And I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, over 1. I gotta fix that, sorry. I should just like freehand it maybe. Okay, there we go. So that's my line, y equals 2x minus 1. And you can see right away, boom, they intersect right here. So these guys intersect at, I always say like their POI, their point of intersection is 1, 1 actually. Yeah, so you can graph any two lines, and what we're usually looking for is where do they intersect. All right, and that is intersections of lines.